I'm here. Thank you, Sean. And
All
welcome
right,
to everybody. The topic we've chosen for today is pressure control valve testing on site. I know that is often the bane of the plumber's life, to try and get a valve out of the installation to replace it because a previous plumber hasn't plumbed with unions or anything like that. So we need to have a look and see what is the easiest way to service it on site. First of all, to know how to service it and to work on it, we need to know the basics of how the valve works. We'll do a quick fault finding and then the recommissioning settings of the valve. Now, I'm going to, for illustration purposes, using one of our valves here, but the principle remains the same for all pressure control or pressure reducing valves. So whatever I'm saying, the same principle applies to all these valves. So first of all, you have your valve in the open position when you get it, mainly because that spring over there is forcing the diaphragm down and keeping the main seat open. So your water comes in. Most of the valves have got a little fine mesh strainer there to keep any dirt out. The water will then flow through and down there. As the water pressure starts building up, it's pushing up through a little bypass valve, and you can see that on the bottom of this cartridge there's a little hole. Other valves have got different ways of getting it there, but all of them will take some of this downstream pressure, put it underneath the diaphragm. As that pressure builds up, obviously the water pressure then starts forcing the diaphragm back up again, and you then get the valve shutting off. Okay, so first of all, we all know that the valve, any mixing point, should have balanced water pressure. So the first question we have is, how do we test for it? Can we test at the garden tap outside? Well, first of all, SANS recommends that your garden taps and high flow items are taken off the line before the pressure control valve or pressure reducing valve. So normally, no, you wouldn't be able to use your garden tap to do a balance pressure reading. You can check your mains pressure there, but not your balance pressure. What you can use is your mixer in the house. The only problem there is that the front outlet hasn't got a standard BSP thread. So unless you have an adapter to fit on there, it is not comfortable to do it there. The easiest way would be then to use a shower. Just unscrew the shower rose, and then most of your gauge sets would then have an adapter that would allow you to go onto there. So if we can imagine, you have your balanced takeoff there with a flow restrictor. Normally, most of your taps these days have got flow restrictors, and then you would have even pressure on both sides, on hot and cold, the same pressure, and that would then be your balance pressure. But as soon as you have an unrestricted cold water supply, your mains pressure will normally be quite a bit higher than what your reduced pressure is. You still only get the same amount of water flowing out the front of your restricted outlet, so somewhere that extra pressure must cause a difference. And what it does is it pushes back into the line, into the geyser, and you guys all know how beautifully clean it is inside our geysers. There's a lot of sediment and rubbish sitting in there, so when this water then pushes back, then it takes all that debris into suspension and dumps it onto the main seat of your pressure control valve. That then lodges there and the valve cannot shut off, and hence the valve becomes faulty. Not faulty, but it's malfunctioning because it cannot shut off. So When you arrive on site, you want to be testing this valve. Most people take the first thing, you go to the back of your van and you get your whole toolbox out and you now want to start working. Not necessary. To do your testing, first of all, you can leave all your tools in the car. All you need to do to know if it's expansion is to go and turn off the electrical supply to the hot water cylinder. Because why would a valve start dripping or expanding? It's expanding because it's getting hot. It's getting hot because the power is on. So if we turn off that power, it'll immediately stop expanding because water is not compressible. So it'll quickly balance that out. If it has stopped dripping now, we know it's normal expansion. Just a quick caution, don't have a look at the outlet on the bottom on the shoe of a gutter or something like that, because if the expansion valve is dripping into a gutter, there could be moss and leaves and all sorts of stuff in there. So that makes like a little reservoir and it's going to carry on dripping for quite a bit longer than what it actually is. So have a look at the actual outlet of your expansion valve and check and see if it has stopped dripping there. If it has stopped dripping, we said normal expansion. If now it hasn't stopped dripping or running, if you have a isolating valve before the geyser valve, you can turn that off. What you're doing now is you're isolating any water coming into that installation through that geyser valve. So it should stop running because there's no more water coming from anywhere. If it doesn't stop running when you've turned that water off, and I've had that, it is because old houses often had more than one cold water inlet, and it can be that there's an unrestricted inlet somewhere on that house and it's got cross-connected and it is pushing water back through that geyser valve. We would have to fix that up. Remember that putting a non-return valve on the hot water outlet of the geyser is not a guarantee that you are now balancing the water. You're not balancing it. You're preventing that extra pressure from pushing back. But your non-return valve is also not a fail-safe. It can get dirt and so forth stuck on there, and it can still cause back pressure. Now, the question is often asked, how much water should the valve leak? Well, it's going to leak while there's heating taking place. So there's a quick little formula that you can make a note of, and it's H minus C times L times 0.0004. And see, the internet is a little bit slow. Okay, there, most of you have got it there now. So H minus C is the difference in temperature, your delta T, times not the size of the geyser. That liters is the amount of water that you've heated in that time period. And then the times 0.0004, 0004 being the expansion coefficient of water. So in this example that I've put here, I say we've heated the geyser to 65. The water starts coming in at 10. I've heated approximately 175 liters times my 0004. And if I calculate that, it gives me 3.85 liters. So for this, it is 3.85 for the time period that I've measured it for. You can measure it for an hour, for 24 hours. You just got to have to make sure you know how many liters you've heated up. Also, the hot water, don't say, yes, my geyser is set at 65, so it's going to be heating to 65. Actually measure the temperature of the water, because what often happens is when a geyser is overheated, the thermostat has gone faulty, and the TP valve opened. Yes, you guys all change the TP valve, nice. You change the thermostat, but very few people actually straighten the pocket, the thermostat pocket. Now what happens is when the geyser overheats, that droops, and then when you put your thermostat back in again, it's not going in nice and clean, and it's actually forcing it into a little arc, and that takes the accuracy of the thermostat away. So make sure when you replace the thermostat, you also straighten the pocket there, and then you know exactly what the temperatures and so on the liters are. So if we now get to the installation, the topic is the valve is leaking. So first of all, we're going to get to the site there and we have a look and see, yes, the valve is leaking and I need to check the set pressure of the valve. Now, what is the set pressure of the valve? And I'll just put that on your screens there quickly. There is a little chart with all the different pressure ratings, 100 being blue, black 200, brown 300, red 400, green 600. And you'll see all of them, there is a set pressure. That is where where normally the valve will close for the first time. So you're going to turn the water on, water's going to start flowing through, pressure building up, and it's going to shut off. On 100 kPa, it's going to be between 70 and 85 kPa. So don't be alarmed if you get to 100 kPa valve. Now you're checking the pressure and it's only giving you 70 kPa. It's absolutely normal. Then when the water is now heating up and pressure is building up in the system, it will start dripping or expanding at about 95 to 100 kPa. Now, how are we going to remember this whole chart? Because, I mean, there's a lot of figures and so forth. You don't have to remember the whole thing. All you have to do is remember the 100 kPa because that is a percentage of the pressure. So if you look at 70% of a 400 kPa valve, for instance, is 280 kPa. Of 600, it's 420 and so on. So all you need to do is remember that 100 kPa as a percentage, and you can actually calculate any one of your valves set pressures. So if your set pressure is correct, but the valve is still dripping, we know that it must be the expansion valve. And if we then go to the expansion valve, a lot of your expansion valve these days have got a little easing gear or lift mechanism so that you can flush the system. So you can just ease that. All it does is it just pulls the seat open for a bit so so that water can flow through and any lodged dirt there can be flushed out. Once you have done that and made sure that it resets and the valve now stops dripping, you've sorted the problem out. It was just dirt on the expansion valve. So then that part of the test would have been complete. But if the set pressure was not correct, so you get to the valve and it's already, say, on 400 kPa and it's pushing water out, we know the valve is not shutting off. So now we need to go and have a look at the main seat of the valve. So in my case, that is what the cartridge on the inside looks like. And as part of your cartridge, at the bottom, you have your main seat where all your water flow happens. So you've got to make sure that that is cleaned out and there's no dirt trapped in there or anything like that. Also make sure any of your O-rings have not been cut or perished or anything like that. And also make sure, just move the spindle backwards and forwards, making sure that it moves fairly freely, because line scale can build up on the brass spindle and it can cause the valve to then malfunction. Also, you have to have a look at the bottom of the cartridge there, and it'll appear in your pictures just now. You'll see there's a little hole, it's a bypass hole that we spoke about earlier. Make sure that that is clear, because if that is blocked, no water pressure can now go and sit underneath the diaphragm. The spring's going to keep it open all the time, and the valve is not going to shut off. So we've got to make sure that that flow of water to under the diaphragm is working 100%. If now we put the valve back together again and we don't have any expansion or leaking, we know we have success. Everything has worked 100% and we have now serviced the valve. We've cleaned it out. So we now get to site, and on your screens you'll see a typical installation of a valve. On your pressure reducing side on the one side, it's got a strainer and everything on it. It's got red caps, so we surmise that it is a 400 kPa valve. The tools that we need now to check this valve to make sure that the settings are correct is a pressure gauge set. And we spoke just now as to where we need to check the. No, we cannot do it from a garden tap, but what you can do is you can go inside the house to a normal bib tap, a washing machine tap or something like that, and put the gauge on there. Or as we said, you can go and actually have a look at the shower, take the shower head off, and that's quite easy to do it there. So in this case, being a 400 kPa valve, if I start checking my pressures, I turn the water mains on, I leave the electricity off still, and I get 3 bar or 300 kPa pressure, I know my valve set pressure is 100%. Now I want to see where the valve is going to expand and start dripping. I turn the electricity back on, so now it's going to start heating the water in that geyser. My pressure is going to build up, and I watch and I see where the valve starts dripping. When it starts dripping, I take a pressure reading, and it should be approximately 400 kPa. If that happens, we know 100% the valve is good to go, and we can recommission it, switch everything back on again as we have, and we have sorted the valve out. That is my quick part of the session there. If you have any further questions afterwards, you're welcome to phone me, drop me a text, drop me a mail, and I will try and answer questions that haven't been answered in the session. But I do see that there are some questions that have come through, so we'll ask Sean just to go through them for us, and I'll try and answer them as quickly as I can.
All right, perfect. Thanks, Patrick. Just quickly, would you like me to send your email out through to the audience?
You can do that, yes, thank you.
All right, perfect. Right then, straight into the first question reads, how do you straighten the thermostat pocket from the exterior of a geyser?
Okay, you can buy, I'm not sure where you're going to buy it, but they are available as a pocket straightener. Most of your electrical stores that do sell thermostats and so forth will sell them. Failing that, if you measure the inside of the thermostat pocket, if I remember correctly, it's about an 8 millimeter. If you get a piece of stainless steel rod, about 8 millimeters in diameter, round the end off nicely, so when you push it in, it's not going to tear the copper, and then just push it through gently, not force it. Make sure that it's not too long so that you're going to knock the end of the pocket off. But just push it in and it should straighten it out. When you put your thermostat in, it should go in easy all the way right up until that little flange section at the back that's spring loaded that must now hold it in place. So the whole thermostat must go in nicely.
All right, perfect. The next question we've got here reads, the distance between this PCV and the hot water cylinder, is this distance manufacturer specific? Or Cobra Masterflow specifies 1 meter max for 100 kPa, 2 meters for 200 kPa, and 10 meter for 400 and 600 kPa. Quickot does not have a brochure in their box as Cobra, but phoning them, they also agree with the Cobra spec. Would this be a fail if the PCV is further than 10 meters away?
Okay, SABS or SANS 10254 says that the valve must be as close to the geyser as possible, but on 100 kPa, no more than 2 meters below. And after that, it carries on saying that it is manufacturer specific and so forth. The reason for these distances is, for instance, on a 100 kPa, your set pressure there is already 70 kPa. For every meter that you below the geyser, you're losing 10 kPa. So on a 2 meter, you're losing 20 kPa. So you're only going to be getting 50 kPa set pressure at your geyser. Now when you open a tap and you've got friction losses and so forth happening, your user comfort is almost going to be zero. So the closer it is, the better for your user comfort. Obviously, yes, higher pressure valves can be further away, and normally 10 to 12 meters on a 400 kPa below is a good maximum distance, but it shouldn't cause the valve to fail if it is further away. All it means is that you're not going to be getting the good user comfort at the end of the system.
All right, perfect. Well, that is all of the questions I have got for you this morning, Patrick. Would you like to go ahead and end off from your side?
Okay, great stuff. Thanks, guys, for all of you attending. We've got a nice audience here this morning. As I say, once again, Sean has sent you my details also, and I have got it on the screen currently. You're welcome to any time. Drop me a line, and if we need to meet you guys on site and help you, by all means, we'll be willing to do that. Enjoy the rest of your day and the rest of your weekend.
All right, perfect. Thanks so much, Patrick. And guys, just from our side, thanks so much for joining us this morning. I am going to go ahead and end the session off now. Please remember the survey on the way out. And once again, a big thanks to this morning's sponsor, Heattech, for helping us bring these sessions to you. Other than that, guys, enjoy the rest of your week. Bye, guys.